right, people, welcome. Let's get ready to learn about something called stellar nucleosynthesis. Sounds fancy, right? Okay, so hopefully you've already watched the video or you remember from being in class. We talked about the Big Bang Theory, right? How we think the universe first began, and that during this time, so we're talking like first 20 seconds of the universe existing, we believe that helium and lithium were made, and also hydrogen. So the simplest elements that we know of, the smallest atoms. But also we've talked about that these elements can get made inside the core of stars. So mainly we've talked about just helium getting made. So hydrogen atoms combining together to make a different kind of atom, a helium atom. So that happens inside of stars like our sun. And today we're going to talk about how some of the other elements get made. Okay. So we've talked about hydrogen, helium, and lithium, but now we're going to talk about some of these other highlighted elements. And how do they get made, right? Because they don't just come from nowhere, they have to come from somewhere. Okay, so let me move my picture here a little bit. I want you to think about a balloon, right? Why is the balloon inflated? If you could see the atoms that are inside of that balloon, what do you think they might be doing? Okay, so get your notes page ready now. Right, so a lot of people, when we did this in class, gave answers like, the atoms are probably moving around, or the air is moving around. Maybe it's hitting the sides of the balloon and kind of keeping it inflated. And that's correct, right? There are air molecules moving around in here. And so I'm going to make an analogy here and say the sun is a little bit like a balloon in a way. It's not really like a balloon at all, I realize, but just pretend with me, okay? We can think of our sun as kind of like a balloon. And I say that because there's atoms inside our sun too that are moving around. They're moving around a lot faster than the atoms in a balloon because the sun is very hot. But still, there's atoms moving around. Okay, and what happens is because those atoms are moving around just like a balloon, they're putting pressure on the inside of our sun. And so those atoms are pushing our sun outwards and keeping it like big and inflated, if you will. Okay. On the other hand, geez, my picture is really in the way here. Gravity is always trying to push inwards. Okay, so that's gravity, those purple arrows. So you have these kind of two opposite forces, like the atoms pushing out and gravity trying to like push in on the sun. Okay, so there's kind of this perfect balance of these two forces. And while the sun's doing this, right, we've learned that it's turning hydrogen into helium, but eventually our sun is going to run out of hydrogen. And so there's just no more hydrogen to make helium. And when that happens, the atoms inside slow down. Okay, so before that pressure was balanced, the outside pressure and the inside pressure of gravity were in like a harmony. They were balanced, and so our sun was kind of staying the same size all the time. But when the hydrogen runs out, the atoms slow down. So now all of a sudden, they're not really pushing out anymore because they're just kind of like going slow. They're not really doing much. Okay, and this takes a really long time in terms of our lifespan. So after about 7 billion years, a star will run out of hydrogen and those atoms are slowing down. So what happens is, like I said, the atoms aren't moving around to push outwards anymore. There's just not enough energy to keep the sun like inflated, if you will. So without that outward pressure, gravity wins. It takes over. It makes the sun get smaller. The core of our sun becomes smaller. It collapses because gravity takes over because there's no longer that outward force. Okay. And I'm just going to ask you, we're going to go back to our balloon now. So what happens when you make a balloon smaller? If you have an inflated balloon and then all of a sudden you try to squish it so it becomes smaller, what do you think the atoms inside are doing? I'll show you a little simulation here. I think it's this one. Nope, it was the other one. Okay, so here we have a person's finger, a giant finger, and we're just pretending, right, here's some atoms. If we could put some atoms inside of a can and somehow make it so there was no way they could escape, what would happen if we push down? Right, so this is just like a balloon. If we're squeezing our balloon smaller, we're making that space smaller. Watch what the atoms start doing. If we really increase the pressure, right, they go crazy. It might be a little more visible with these water molecules. Okay, so they're moving around. The smaller we crush that space, right, the faster and faster those molecules start moving. Right, so they're going crazy. And the same thing happens in our sun. Oh boy. Okay, hold on a second here. There we go. Right, so just like that can or a balloon, our sun, when the core collapses, all of a sudden there's like more pressure than there was before. Okay, so what happens is it makes those atoms that were slowing down, now they start getting faster again because we've increased the pressure. So, just like in regular fusion in our sun, when hydrogen atoms are moving really fast and they combine together because they're going so fast, they make helium atoms. This also happens even after our sun runs out of hydrogen. So in this case, these are right here, these are helium atoms, and they start going really fast because our sun's out of hydrogen, but there is helium in there. So the helium atoms start going fast. They smash together, stick together, and they make a different element. In this case, it's carbon. Okay, so you can go ahead and write that on your notes page right here on the bottom. The atoms with 2 protons are helium atoms, and they combine to make carbon atoms. All right. This was just a little practice. When we were in class, it was to help people practice using the periodic table to figure out, okay, if an element has 6 protons, which element would that be, right? And you probably know, because you're smart, that, right, you would just find the element that has a number 6 above it, and that is the element that has 6 protons. And you would say, it is carbon. Okay, so that's what happens in our sun. First, it burns hydrogen, fuses hydrogen together to make helium. Once it runs out of hydrogen, then the helium atoms start moving, and they combine together to make carbon. Okay, and then after about 500 million years, the helium starts running out. So our sun's run out of hydrogen, it's run out of helium. All that it has now in the core is a bunch of carbon, and those atoms start slowing down again. Okay, but what happens is the same as before. Now, because they slowed down, there's no pressure pushing outwards, and so gravity wins again, and it makes the core of the star even smaller. Okay. So you could probably guess what happens from here. Those carbon atoms that were slowing down, now they start getting all fast again. And they actually end up combining with some of the helium. There's a little bit of helium left over. And so they combine to make some new elements. The first one has 8 protons. So flip your notes page over. Okay, and if you had a periodic table, you would be able to look at it and say, okay, what element has 8 protons? You would find the element that has a number 8 above it, and you'd say, that's oxygen. Okay, so you're going to write oxygen here on your notes page. These elements also combine to make atoms that have 10 protons, neon, and they make atoms that have 12 protons. Magnesium. Okay, so you're filling those 3 out on your notes page. This is really just practice using the periodic table. Okay, so this happens over and over where it gets really hot because of the pressure inside of a star. The atoms start moving again, so they fuse together to make new elements. Eventually they run out. They start going slower again. Then the core gets smaller because gravity takes over again. And it just keeps happening over and over. Okay, so in this case, carbon and helium make these new elements. Eventually, we run out of carbon and helium, but then magnesium and neon create more oxygen. Okay, and so the core of our star just keeps getting smaller and smaller, where every layer, it leaves behind a little bit of the element that was fusing or going through fusion. Okay, and this is the last one on your notes page. So we have oxygen atoms, which have 8 protons. And they combine to make an element with 14 protons and some helium. So if you had your periodic table, you would look at it, you would find element number 14. You'd say, I know that has 14 protons. And you could see, that's silicon. Okay, so you're going to write silicon here. And we'll just speed through the rest of this. All right, so there's more and more elements getting made. Silicon, and the last one is iron. Okay, and after iron, there's just not enough pressure for a star like our sun to make iron atoms hot enough to fuse into other elements. So iron is the last stop. Okay, you can skip that second to last question on your notes page that says, what are some ways calcium could be made in a star? Forget about it. Okay, so at the end of its life, a star is kind of like an onion, and it has a bunch of layers that have different elements. And this process of stars making new elements by combining atoms is called stellar nucleosynthesis, which was the title of this slideshow. Stellar just means star. Nucleo is talking about the nucleus of an atom, because really it's the nucleus of atoms that are combining. And then synthesis means to make. Okay, like if you're synthesizing something, you're making something. So this is really just a fancy science word for saying when stars make elements. All right, so these elements that are highlighted yellow, all of those are made inside of stars while they're alive, including stars like our sun. Our sun's doing this right now. It's not making things like iron yet, but well, actually, our sun won't make that. It's not big enough. But it will make elements up to carbon. Bigger stars can make iron. Okay. You're not going to do a self-reflection. That's it for this topic. If you have any questions, let me know, and good job.